All right, so we're going to use reference angles to help us find all 6 functions of 240 degrees. So first of all, we need to draw an angle in standard position that's at 240 degrees. So if I come over here and create a coordinate plane, my initial side is here. This is 180 degrees and this is 270. So we're going to rotate over here. This is an angle of 240 degrees. But remember, when I'm doing my 6 trig functions, they have to refer back to one of the special right triangles of 30, 60, 90 or 45, 45, 90. So that means I need to know what is this reference angle. So the reference angle is equal to 240 degrees minus 180 degrees. And so we end up with 60 degrees as the reference angle. So what I'm going to do is I'm going to drop a triangle in here. And I know that this angle is 60 degrees. Get rid of this. So this is a 60-degree angle right here. Okay, so we're going to use the idea of the unit circle, and that is saying that the radius is 1. So this is a unit of 1. The 90 is over here. So this is going to be 1/2, and this is going to be the square root 3 over 2. Okay, so once I know that those are my measurements, then I can go ahead and find my 6 trig functions. The other thing, sorry, I forgot one thing. We are in quadrant 3. In quadrant 3, this value is negative, and so is the 1/2. Okay, so we should also make those signs appropriate. All right, so if I go to sine 240, sine is the opposite over the hypotenuse. So the opposite of 60 is square root 3 over 2 over 1. So we're going to take the negative square root 3 over 2 all over 1, which is just the negative square root 3 over 2. The cosecant is the reciprocal. So all I have to do is reciprocate 2 over the square root of 3, and it's negative. However, I can't have a radical in the denominator, so I'm going to rationalize it and get 2 root 3 over 3, and that value is negative as well. The cosine is the adjacent over the hypotenuse. So adjacent to 60 is the negative 1/2, so I'm going to take negative 1/2 over 1, which is negative 1/2. If I take the reciprocal, I get negative 2 over 1, which is just negative 2. The tangent is the opposite over the adjacent. So I'm going to take negative root 3 over 2, this gets a little messy, over negative 1/2. Well, remember we can write fractions horizontally. So what ends up happening is keep, change to multiplication, and flip. So the 2's end up canceling, and I'm left with a negative over a negative, which is a positive square root of 3. Okay, the cotangent is the reciprocal. So if I reciprocate, then I have 1 over the square root of 3, because remember we can put in an imaginary 1. Well, it's not imaginary. And so if I reciprocate that, rationalize it, I get the square root 3 over 3. Okay, so all of that came from using the 60-degree reference angle and their knowledge of special right triangles. For number 9, let's just go forth and continue with the quadrantal angles and working with our knowledge of trig. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and also 360 degrees. Now it says also in radians, so I'm going to go ahead and I'm going to label this. This is 0 pi. This is pi over 2. This is pi. This is 3 pi over 2. And this is also 2 pi, 1 full rotation in radians. Okay? Check. All right, so then label with the associated ordered pairs. When we're talking about this, we're talking about the unit circle. So if I were to create a circle each one of these points on the circle would be the same distance from the origin, and it would be a unit of 1. So this is the ordered pair 1, 0. This is the ordered pair of 0, 1. Here's the ordered pair of negative 1, 0. And here's the ordered pair of 0, negative 1. Okay? Now, with the quadrantal angles, one can't form a triangle. So we can't use a 30, 60, 90 or a 45, 45, 90. So to find the trig values, we have to rely on special ordered pairs and the fact that sine theta is equal to y, cosine theta is equal to x, and tangent of theta is equal to y over x. Okay, so if I were to find the sine, cosine, and tangent of each of those values, we would use our y and our x. Okay, and then the last question is, well then, what does the catchphrase, all students take calculus, mean? This means the 4 quadrants, all students, take calculus. It's an acronym for the functions that are positive in the 4 quadrants. In quadrant 1, all 6 functions are positive. Okay, all 6 functions are positive. In quadrant 2, only sine and its reciprocal, cosecant, are positive. In quadrant 3, tangent and its reciprocal of cotangent are positive. And in quadrant 4, cosine and its reciprocal of secant are positive. Okay? All right, so that is 8 through 10.